Well, then, it's been an exciting 24 hours for space weather. So thanks for tuning in to the Daily Space Weather. It'll be an exciting day for the channel also, as it is Solstice Day. We'll be doing at least 3 significant videos, so make sure you join us for the moment of the solstice, as we'll be streaming live for that. This is the past 24 hours from the GOES-R. In 195 angstroms, we'll be talking about X-class solar flares and lots more today at the Smash News Network, least busted name in news. So let's take a quick look at the X-class flare and the massive coronal mass ejections that everybody would be talking about. There is the past 24 hours. We've switched the wavelengths here to 304 plus 131 angstroms. And of course, if you check the lower left quadrant there, you'll see a sudden brightening. That was the X-class solar flare that occurred yesterday between about 1600 and 1800 Universal Time. Don't worry, we've got some extreme close-ups of it as well, as you may have come to expect from the channel. And by the way, thanks to all of our new viewers, subscribers, etc. Don't forget to press subscribe if you are new to the channel, as we bring you the world's most comprehensive daily space weather and most detailed imagery of the sun you'll find in the known universe. Some mushroom-like features there showing up just after that, large solar flare. And don't worry, we'll show coronagraphs and lots more. First, let's take a brief look at sunspots. And there is an uncountably large number of sunspots. Also, another new one has just recently risen in the southeast right down here, so at least one new named sunspot group should appear today on the sunspot lists. Yeah, we'll get to it in a moment. Here's a colorized magnetogram. Huge magnetic shear associated with this sunspot over here in the southeast. And these things are forecastable, folks. You know what else? It looks like there's another new sunspot that's just, yep, sure enough. So we'll have at least 2 new named sunspot groups, another one formed right here also. So it's always good to look at the colorized magnetogram, because it might show you some things that you can't see otherwise. Anyway, there's some very high resolution available, and let's briefly take a look at what's going on Croissant Earth. Yeah, Croissant Earth. It's croissant-shaped. Stop believing NASA's lies about a spherical Earth. Don't you know about Operation Paperclip? What are you, some kind of an idiot? Pardon my sarcasm. Mount Mayon continues to erupt, which is what's featured here. Some effusive glowing lava blocks and lava flows there on Luzon Island, Philippines. Looks like about a 1,000-foot ash plume there, or about a 2,500-foot ash plume there, 800 meters. Semeru also exploding on East Java, Indonesia. No indication on the ash plume size there. Something like 2,000 feet. Popocatépetl exploding in central Mexico, flight level 210. Nevado del Ruiz exploding in Colombia, flight level 200. That's 20,000 feet above sea level, the top of that ash plume. Sangay exploding, flight level 190. Cotopaxi has dispersed its ash, and Sabancaya in Peru exploding, flight level 210. It's a 21,000-foot plume of volcanic ash over Peru. Today's featured product is MAXA, which stands for Make Astronomy and Cosmology Science Again. Yeah, Make Astronomy and Cosmology Science Again. It's one of the chief efforts of the channel. I realized back in the 1990s, around 95, that there's a huge hole in cosmology, and that hole is in heliophysics. That's what brings us to these space weather videos. I'm currently doing them because of cosmology. Also, it will advance human technology. Why? Because of superionized materials. Yeah, superionized materials like liquid metallic hydrogen, solid metallic hydrogen. And don't forget superionized water, which is even weirder, by the way. Superionized materials aren't just the future of cosmology, they're also the future of human technology, in some people's opinion, like mine. And there are a lot of advances coming, like free electricity. But let's just continue on here. That featured product is available from the Redbubble shop. You can find the links on the homepage and below this video. There's also a paid endorsement from Hemp Lucid. Don't forget to enter the promo code SMASHOMASH. That'll save you 10% on your checkout for your Hemp Lucid orders. HempLucid.com. Enter the promo code SMASHOMASH to save 10%. Why not save some dough? Why not try out some mushroom gummies? I like to use the Focus mushroom gummies. So focus your health on improving it, perhaps with some of the products from Hemp Lucid, hemplucid.com. Enter the promo code SMASHOMASH and save 10% on checkout. We've also got an affiliate at Amazon. Today's featured product is the Drive Medical Adjustable Non-Tilt Overbed Table. It's a great way to supplement your office furniture if you need a nice rolling desk. It's even super convenient for your living room if you like to eat standing up, for example, or if you just want a rolling table in your living room. It's a pretty good deal, $55 there. They do have 2 locking wheels. You can find them on the Amazon store, amazon.com/shop/smashomash, also linked below the video and on the homepage. And let's see what's going on seismically across planet Earth. There's the 90-day bar graph. No major quakes in the past 24 hours. We'll cite quakes of a 5 magnitude or higher, like this 5.2 at Tonga, which struck at 15:41 Universal Time yesterday afternoon. Did I say 5.1? I meant 5.2. Anyway, 5.0 also struck that same area. It's been the most seismically active region for the past week. There's a 5.7 in that same area there at Fiji. That was at 19:59 Universal Time yesterday evening. Also a 5.0 hit Japan at 23:33. Southern Mid-Atlantic Ridge saw a 5.5. Iran had a 5.0. That was at 5:12 Universal Time. And that closes out the list of quakes. So let's get back to some solar imagery here as we return to the sun. That's the past 24 hours from GOES-R, 171 angstroms. Here we've added 304 angstroms. And there's a massive CME actually occurring as we produce this video. It's coming from this area up here. And there's a huge plasma filament up there, and it is behind that plasma filament. There's lots of plasma still intact. We'll show you here a little bit later in the video before we do the meteorology segment. Now we've put together 284 plus 304 angstroms because we're using the GOES-R imagery today. Why not show some wavelengths we don't normally show on the channel? There you go. And don't worry, we're not going to skimp on showing close-ups of that solar flare. 10.7 centimeter radial flux is now at 180 solar flux units. And there's the one-day graph of the radial flux to put that in context for you. 180, having broken out of most support levels here. Is the sun off to the races? Let us know what you think in the comments. Is it going to promptly get back over 200 for the 10.7 centimeter radial flux depicted by this black line? That is a one-year graph from Solon.info. The red line is the sunspot number. Space Weather Enthusiast dashboard here, not forecasting any geomagnetic storms or geomagnetic unrest. That's the NOAA forecast. So if you want to follow those NOAA forecasts instead of ours, good luck with that. As we have been displaying shocking accuracy. So let's take a look at Earth's magnetic moment from space. Here's the past 4 hours of magnetohydrodynamic pressure. Earth's magnetic moment from space, folks. The magnetosphere is not going away. Otherwise, this would look differently. Now, keep in mind it is at maximum diffraction here because today is solstice day, which means Earth's axis is about to start swinging back the other way as the sun returns to the southern hemisphere. Here are the last 4 hours of Earth's magnetic moment from the ground. And of course, if we were seeing an actual geomagnetic pole flip, a magnetic pole flip, etc., you would see quadrupoles forming on this imagery, but you don't because it's not a thing that's actually occurring. I don't care who tells you on YouTube that it is. There are the facts. 4 hours worth once again today. Planetary K-index is only at 1.67. So KP 1.67 is a geomagnetically calm condition. Now let's take a look at what's going on at Lagrangian point 1, the location where the solar wind is measured outside Earth's magnetosphere, where it can be measured. Current solar wind density is about 8.5 protons per cubic centimeter. Solar wind speed about 450 kilometers per second. Besides that, it's pretty unremarkable for the solar wind. GOES magnetometers here showing some variations here. Those came through in the last hour. It's probably a shifting of the magnetic field to the solar wind. That's the past 3 days as measured by the GOES 16 in red and the GOES 18 in blue. Let's take a look at the heliospheric current sheet next. Most important feature being this green blob up here, as it is still not leaving the north heliographic pole, and until it does, we will not declare that it is solar maximum. So that's depicting the solar plasma there in all its polar glory. There is a North Pole current sheet headed this way. It looks like there may be a delay, an indication of, well, perhaps another huge sunspot in the northeast, and I'm pretty sure there is. We'll tell you why that is the case a little bit later in the video as well. So lots more to cover here. Line of sight field plot. Lots of organized magnetic fields on the Earth-facing side of the solar disk. Earth remains in a south pole current sheet. You can see the sun's B field depicted here in blue. And let's move to coronal holes. Coronal holes, super important for solar cycle progression. And there is the coronal hole line of sight plot. We've got some North Pole-oriented coronal holes rotating in here in the southeast. Again, another likely sunspot rotating in the northeast. We'll talk about that shortly. You can expect these North Pole-oriented coronal holes down here to become much more well-defined in the coming days. You can see one opening up here right on the equator, and that is actually a South Pole coronal hole right there. So that can actually cause a little bit of space weather there, especially if it continues to become more well-defined. That's the past 24 hours from SDO, 211 angstroms, the top wavelength to view coronal holes. And let's move to sunspots. Again, we'll have at least 2 new named sunspot groups, one here and one right down here in the southeast. And that is, I think that's the longest list we've ever had. As many as 16 active regions there showing up on the ASAP solar flare monitor. Likelihood of X-class flares remains very, very high. And again, these things are predictable, folks. This is well documented in the scientific literature. Solar flares can be predicted. It all has to do with magnetic shear. And if you look really closely at the magnetic fields, you too can forecast sunspots. Let's move on to take a look at them once again here in SDO. There is the SDO continuum. That includes yesterday plus today, and we're going to zoom in on the equator here for maximum detail. That is an incredibly large number of sunspots. And again, folks, we aren't yet at solar maximum. It's just a fact, and it has to do with, well, lots of different data points. Again, we expect to have at least 2 new named sunspot groups today. Whether that'll increase the sunspot number or not might be another story, as there's quite a magnetically complex group setting down here. And by the way, yesterday's forecast about this group being likely to produce large flares was not incorrect and has not ended. That is still a beta gamma delta class sunspot group. It still does have a high likelihood of producing large flares. Also, the likelihood of a large flare in the northwest. So that western limb there becoming increasingly likely to produce large flares. Let's move to solar energetic particle events. We ain't got none. Despite an X-class flare yesterday, no solar energetic particle events. Evidenced there by the GOES 16 proton flux. So here's this flare. Peak flux was around 1710. It was an X1.09 class flare. It lasted about 2 hours. If you want to make your own custom videos, go from 1600 to 1800. 1600 to 1830, actually. That'll give you some great views of those flares. Once again, a smaller flare here happening while we produced the show today. And let's take a look at, there's 94 angstroms, 24-hour video for you. And there goes that X-class flare. Once again, this is the GOES SUVI in 94 angstroms. We've also got some additional wavelengths for you here. Here is 94 plus 304 angstroms. We've added the ionized helium wavelength of 304 angstroms there. We'll also show 304 by itself, as different wavelengths do show different features, because different species of ionized gas have a tendency to align differently to magnetic fields. It has to do with the number of electrons they have in their shells. I'll just leave it at that. Keep in mind, folks, high school level physics is sort of a prerequisite for our channel. Here's one of my favorite wavelengths of all the wavelengths we ever show on the channel, 195 angstroms. So this is a really good one from the GOES SUVI. The SDO does not cover 195 angstroms. The GOES-R does, and that is pretty sweet. You see that mushroom-like feature there forming. And also 284 angstroms, another wavelength the SDO does not include. The GOES-R does, so we took the opportunity to show it to you today. It's another species of ionized iron, by the way. So there's the full disk view for the last 24 hours in GOES-R 195 angstroms. And it's time to talk about space. Yeah, we spend a lot of time on the Smash News Network, these busted name of news, talking about space. And I take no prisoners when it comes to that. Because, well, I've been doing this a while. Yeah, I've been a cosmologist since since about 1979, when I was like 3 years old, when I first read about cosmic rays. So here we've brought up some SDO imagery just to show some more close-up detail of this X-class flare. We've paused that at 1724 Universal Time, and we've slowed our way down here to show some spectacular solar flaring there. So there's a great slow-mo sequence in 94 angstroms, and we'll also bring up, we're going to show 131 as well. These are the two best wavelengths to view flares from SDO. So there we go, we've slowed that down. Again, if you make your own custom video on this one, you could use 1600 through 1830 Universal Time. If you want to get just the flare, put it in ultra slow-mo, zoom in, etc. Keep in mind, today is the solstice day. Yeah, solstice day. It's the longest day of the year by far. And that's what's going on overhead in terms of stars right now. As the sun is about to start to return to the southern hemisphere, here's your solar system forecast. That's the location of heavenly bodies today. That's the location of heavenly bodies in 1 week. That is, besides the ones that tune into our videos. Anyway, there's the countdown. Only 3 hours and 42 minutes left from the time we made this video, which means we got to speed this thing up because we'll be streaming live at the moment of the solstice. So let's get this thing onto the TV. Make sure you join us for that, the June solstice 2023 video. It'll start about 10:30 Eastern Daylight Time. Also, make sure you join us on Twitter if you do the social media thing. If you've unplugged entirely, we understand why, because the censorship is truly pathetic. By the way, yesterday we created a short about the pathetic censorship, which, guess what? Got censored through demonetization, which does not recommend the videos and causes them to be buried in search. We are also on Instagram if you want fitness and lifestyle posts and motivation to work out and things like that. Join us over on Instagram. And here's yesterday's coronagraphs, and there's a huge CME that pops off there in the northwest, also in the west, and then of course in the east. And that CME may have earthly directed components there. I suspect it probably doesn't. We'll get to why here in a minute. After that plays through once more, here are today's coronagraphs, and again there is a huge CME popping off in the northeast as we make the video, which we'll show you here in a minute. So here's the Soho Lasco C2 and C3. 3 major CME events, one of which is occurring right now. You should just see it happening there in the upper left. We're going to talk about that northwestern CME here for a minute as well. So first we're going to show stereo A because it shows some great images, obviously. And we show this diagram to show people the locations of the solar orbiter, Parker Solar Probe, Bepi Colombo. Stereo A and B there shown in red and blue respectively. And here you have, there's that X-class flare associated CME in the lower left. Now, let me just talk about this northwestern CME for a minute. This is another example of an interesting type of CME. Now if this struck Earth, let's say Earth was right here, If this struck Earth, you would see various different solar wind events happening. You would see a diffuse solar wind, and then a little bit of a lull, and then you'd see a slightly denser solar wind, and then a very dense and intense solar wind, and then that would slowly trail off. So that's another type of CME here. This one's got like a bubble-like feature and a dense core, and even like a neutral zone there behind the leading edge. So these things take all sorts of different shapes, folks, and those shapes are often evidenced by the solar wind telemetry. So, I mean, you can probably derive some predictive value about how the CME would react if it did strike the Earth's magnetosphere. And here's this one in the associated with that X-class flare. And let's do a quick analysis of this. So there's that CME at 19, let's go to 1954. That's a good time. This one could have a minor Earth-directed component. If so, it'll show up early in the day on the 24th. Yeah, early in the day on the 24th. It's not a particularly high-speed CME, just sort of an average speed coronal mass ejection there. And it will be a minor glancing blow if it does strike Earth. Let's show our custom coronagraphs next, featuring the 195 angstroms wavelength, which we've zoomed in on here briefly to show, let's just say, a lot of activity on the Earth-facing portion of the solar disk. And once again, folks, let me reiterate that we are not yet at solar maximum. So here come coronagraphs, and they are totally sweet. Crazy amounts of material coming out of the closest star there. And we've kind of cheated here to the lower left just to mainly highlight that CME that everybody will be talking about associated with that X-class flare. Now on the channel, we don't say that flares cause coronal mass ejections. We just say that they are associated, as many of us believe that the coronal mass ejection causes the flare, not vice versa. Keep in mind, things that are happening at very high speeds are a little bit harder to understand the physics of, right? So there's some great imagery for you. And let's move on to talk about filaments. So massive filaments here continue to dominate the Earth-facing portion of the solar disk. And the one that's ejecting right now is from up here, and this filament is largely intact yet. So let's take a look at that. There's a great filament that could use a name. This S-shaped filament here is still up there. So that would be a great filament to name. Maybe name it after a musician, as it looks like a... Doesn't it look like a bass clef? Anyway. Maybe we should name that one Geddy Lee. The Geddy Lee filament, folks. Anyway, if you want to name filaments, join us on Twitter. Follow the hashtag #NameThatFilament. I don't care. I don't care because the censorship is so pathetic that if you've unplugged from social media entirely, I don't know how you're watching this video, as YouTube is social media, but anyway. So there you can see that CME jumping off in the northeast. Huge portion of plasma still hanging out there. There you can see that filament that I just talked about. Also a crown prominence down here. Filaments, filaments, filaments all over the solar disk. Likelihood of coronal mass ejections remains nearly 100%. And let's move on to our bonus feature segment, starting with satellite charging hazards. So those are non-existent. It's smooth sailing for satellites at the moment, no surface or internal charging. Goes electron flux here in just sort of an operating range. And I believe we are expecting a downtick in the electron flux, having reached into warning levels with both satellites the past 2 days. There is the 1-year graph to put all of that in context for you. That's the relativistic electrons as measured at the F layer of the ionosphere. And here is the forecast model, seeing a little higher levels there than NOAA forecasted. I would expect this to be a little bit lower for tomorrow, but hey, no big deal. Electron flux, there's your NOAA forecast. We'll show the layer of the ionosphere where it's measured. Feel free to pause the video on this frame. And there's the vibrational frequency going on at the bridge between Earth and space. It's about 300 kilometers of altitude, the F layer. And if that's all Greek to you, don't worry. It's showing vibrational frequency in megahertz. We are seeing some significant anomalies here, actually. As we close out the final moments of our spring. So there you can see quite a lot of red there, a lot of low-frequency anomalies, and those were evident to me when I looked at the plane ionogram. This is anomaly in megahertz from a 30-day median. It's shown daily on the channel. If you want to know what was happening on a specific day, you can't access this data in archival form as far as I'm aware, without a special request, I suppose. You can view our videos going back pushing 6 years. Anyway, lots of low-frequency anomalies there showing up as the ionosphere looks like it's puffing up a little bit here. We do have a slightly elevated solar wind and so on, so there is a bit of action happening there. Here's the latest image, 11:15 universal time ionogram and 11:15 universal time anomalygram. We'll also show total electron content. That depicts free electrons through a run like this. It's about a 12,500 mile distance from your GPS satellite to your handset, and here are the free electrons in between that area. So we have been seeing some anomalies here. We are seeing significant nighttime electron contents. The most likely place to see GPS errors is around the equator at noontime, and you can see here some electrons out of place here. Some significant nighttime electron content anomalies there happening around the equatorial part of the planet. So we've shown that. There's the whole planet view, and here is North American 10-day anomaly. It's the last day, but it's the anomaly from the 10-day average. Only minor anomalies happening here over places like the Caribbean of the high electron content variety. Low electron content anomalies, not really something we care about too much. Anyway, here's the latest SDO intensitygram and latest SDO magnetogram. Again, we've got some new sunspot groups. I'm not going to spend a lot of time talking about it, as we just keep getting more and more sunspots and more sunspots and more sunspots. It's like the sun is just thumbing its nose at people who are claiming we are in a grand solar minimum, or that the sun is in a grand solar minimum. What an utter crock of crap. How about looking at reality? Now, you see this line? This line is slanted. That is the solstice line, and that line tomorrow will be slightly less slanted, which means the sun is returning to the southern hemisphere. So that's really what the solstice is, folks. It is the sunniest day of the year for the north. The June solstice is. And what we're looking at here is the UV index. So that's just the UV index there from nullschool.net. I just wanted to highlight this fact. It's the opposite of the equinox, astronomically speaking, in that the equinox features a straight line because you've got equal days and nights across the entire planet. The solstice is the opposite. You've got the longest day in the north and the shortest day in the south. But don't worry, folks. Tomorrow the sun will already be returning to you southern hemisphere types. Anyway, let's move to winds. Check out this low below Australia here. A large low there right on the coast of Australia, creating some onshore winds and so on. That's the surface wind scenario, and some strong winds here in between Kamchatka and the Aleutian Islands also. Also the Southern Ocean featuring some powerful lows. Here is the jet stream scenario for this side of the planet. Jet stream scenario for the central world depicted here. Still blowing backwards over the northern portion of the Indian Ocean. Here are the surface winds for Europe, Africa, and the Middle East. And here are the surface winds of the Americas. And here are the jet streams. Jet streams still all over the place over North America. Extremely anomalous jet stream there. That's what's bringing weird weather. The jet stream. If you think mankind controls the jet stream, take a physics class. Seriously, take a physics class. Now we're looking at the windy.com map. Yeah, windy.com. It's fantastic. And some of the features here we're going to highlight today are soil moisture, soil anomaly, and drought intensity. So there's the soil moisture situation. And if you're wondering if some of those places are anomalously wet, well, the answer is yes. A large band across the center of the country here featuring anomalously moist soil. The north-central portion of the country featuring anomalously dry soil. There's the drought intensity map also. Pretty intense drought there in the north-central U.S., but for the rest of the country, it's largely subsided. Some drought still happening here at extreme levels in Pennsylvania, New York, and New Jersey, also Connecticut. But yeah, the droughts have mostly subsided. And check out California. Only tiny little areas of drought there from Windy.com's drought map. Now we're going to show the visible satellite for once. Once again, showing that great, extremely highly angled shadow, as Earth's axial tilt is responsible for the seasons. If you've got other explanations, if you think that the planet is not a spinning ball, as flat earthers say, well, here are photos of the spinning ball. Not only that, if you've got a single theory to explain the seasons and day-night transitions, we'd be happy to hear it. It's just that flat earthers don't have a theory for that. It's the lowest hanging fruit in the world. And here's a scary fact for you folks. Did you know that more people believe that Earth is flat now than did 2,000 years ago? Yeah, it's pretty easy to prove. I mean, I don't know. I think most of the people out there are just trolling about it. But yeah, more people believe Earth is flat now than believed Earth was flat like 2,000 years ago. Pretty sad, as mankind's thinking devolves. And we've certainly watched it devolve over the past 3 years. Next, our weather.gov map. We've got flooding. We've got freeze warnings in places like Nevada, Oregon, and California. Floods and heat advisories. So lots of weather alerts there. If your location is lit, head to weather.gov. Those are too many counties for us to cover in a video like this. Let's move to some forecasts. Here's your total accumulated precipitation in inches. It's based on the GFS 72-hour model, and you can see there are indeed some heavy rains coming to the southeastern U.S., especially. Also a band of very heavy rains there in Texas, Louisiana, Oklahoma, Kansas, Colorado, Nebraska, South Carolina, and Wyoming, all going to receive 3+ inches of rain there. Again, it's a 72-hour GFS total accumulated precipitation forecast in inches. Here is your GFS pressure and precipitation forecast. Severe weather coming back to Texas. Also South Dakota and Nebraska. Also Montana going to see some severe thunderstorms. Last but not least, temperature anomaly forecast, since there are massive temperature anomalies happening. Quite cold in the eastern part of the U.S., quite cold in California and Nevada. Again, freeze warnings showing up there. Weather.gov is where you can get your warnings. Really hot in eastern Canada. Really hot in eastern Canada. I suspect there is a lot of snow melting. In places like Greenland, that is. Anyway, here's our lightning mapper. That's the past about 10 hours of lightning. Some severe lightning there in Louisiana and Florida, especially as far as terrestrial strikes. Also the central part of the U.S. seeing a conflagration there of thunderstorm activity. Here's a real-time lightning map. Again, we've got the shadow up here. Don't worry, Southern Hemisphere type viewers. The sun is returning as early as tomorrow. Actually, it really starts returning at about 11 o'clock this morning, so in only a couple of hours here. So let's finish out our video. By the way, if you enjoy the content, please support the channel via clicks. You can find our homepage at smashomash.com. We built it back in 2019 because of pathetic censorship. And of course, that was just, we should be thanking Facebook for being such losers at their own jobs. Also, if you want to support the channel via subscription services and you want additional content, things like email alerts, your own email address at smashomash.com, consider becoming a member of the Smash Team, smashomash.com/Smash Team. If you can find the content, you can certainly hire the Smash Team. You can just visit the website and just click on this, or Smash Team. Super easy to find. smashomash.com/Smash Team. By the way, a gold annual paid-up subscription includes complimentary merch. It's like getting 4 months free. Anyway, here's your U.S. Doppler radar map showing all 50 states. Will focus on the lower 48. Strong storms there in Kansas at the moment. Hopefully nobody is being transported to Oz. Here is your clouds and fog view. You can see rapid cloud nucleation happening both in Nebraska and Kansas there. And again, weather patterns will be moving in weird directions because of the jet stream, as evidenced here. So you can see cold air blowing down from Canada across the Great Lakes. You can see the jet stream is just all weird over the North American continent. Check out the rapid cloud nucleation over Louisiana as well. A lot of water vapor showing up there in the sky. Anyway, here is your recap, U.S. Doppler radar. Clouds and fog. And water vapor. Hopefully that clears things up. Hopefully you're able to forecast your own weather. Hopefully you aren't consuming too much nonsense on YouTube. I'm going to spend the last few hours of spring in the bunker. So anyway, see you later. And hopefully you're not seeing all this spooky stuff in space. It's very scary in space. So bye. Back to the bunker with me. Whoa.